Okay, so hello everybody and welcome to this year in Beside Charlotte. I am Ali Kabeel, and today we will be presenting the presentation titled Breaking the Giants with Logic. This is actually the second one in the series, so we had the first part last year and we are having the second part right here today. So let's kick off with some who am I? So I'm a security engineer at Bending Spoons, but just a disclaimer, this talk is not sponsored by my employer in any way, it's just me. I have been a bug hunter and a security researcher since 2014, and we will know what really a bug hunter is in case you are curious about it. My research interests basically revolve around privacy, web application security, as well as network security. And I'm particularly passionate about exploiting vulnerabilities barehanded, and we will know exactly today what barehanded exploitation mean. As a hobby, I like giving talks in several BSides security conferences. And this is my last year here, luckily, so I'm really glad to be with you all. In case you want to find me on social media, so feel free to reach out at Logic Breaker on Twitter and Kabeel on LinkedIn. So enough with who am I, and let's kick into some motivation of today's topic. So before we start, you might have noticed that we talk about breaking the giants with logic. So let's break down the title into two pieces. So the first piece, which is breaking the giants, and by the giants, we mean gigantic companies, basically the big player, the one that have massive amount of data centers and data stored. Examples are Facebook, Instagram, Google, Snapchat, and so on. So we want to break those. We want to break something as big as that using logic. And now let's talk a bit about what logic is. And I must apologize to anybody who have ever been into a formal logic class. This is not what you're expecting. We are talking about informal logic, something that's really simple. So informally, logic is what people think is right, what people think makes sense. So if I told you that in the middle of the summer, it's going to be freezing and it's going to be snowing, for example, you're telling me this is nonsense, it's not logical. Why? Because it is not what we know. It's not what the common sense agrees on. So logic had been there for years, and it's actually since eternity that it's the core of mathematics, physics, and computer science, people reasoning about things. This is what logic basically is. And let's just take a look away from security at a very simple logical bug. So let's see this function defined in Python. It's obviously an addition function. So you just take two arguments, x and y, and it should return their multiplication, their addition. And as you can see here, what's basically returning is their multiplication. So if I printed add 1 and 2, basically I'm expecting 3, but this is not what's happening. So will the code run? The code will definitely run. Does it have any syntactical error that would be code during interpretation time? Nothing at all. The code will run perfectly, but it is not the result that you are expecting. It's not a logical result. The addition of 1 and 2 is 3 and not 2. So this is basically a very simple logical bug. The program runs, but it's not doing what it's expected to do. Of course, this is very simple. It has almost no security impact, but it is just to demonstrate the idea of what a logical bug can be. So let's take a sideway a little bit and talk about the life of a bug hunter. So for those of you who don't know, bug hunting is basically finding security vulnerabilities in companies and reporting it to them under what we call responsible disclosure policy. You basically find the vulnerabilities, and if the company accepts you to report those, you just go and report them. If the company does not have this policy, you are not authorized to do so. So don't go along just attacking people. This doesn't work that way. It just be under a policy in that case. So there is really a bad struggle in bug hunting that you may find a security vulnerability in one website and then go and think that this is a really good vulnerability, and in fact it is. But then you go to them and they told you, okay, this is a duplicate. And by duplicate, we simply mean this bug has been reported before. We are sorry, we are not paying you anything. And now all the work that you have done is done for nothing, basically. So now, as you can see in this meme, duplicates are really bad. You find really something very effective, but instead of it paying off, you just end up in pain in that case. So a good question that I asked myself, because I've been a bug hunter for many years, like, why do duplicates happen? So basically, duplicates happen because people overly rely on code vulnerabilities. They always rely on things related to remote code execution, related to cross-site scriptings, vulnerabilities in the code itself. They don't really go into the application logic. They don't understand the business model of the website, usually because this takes a lot of time and people just want like what we call hot cash. So they just report vulnerabilities right away, without trying to understand the business model or the goal of the business in that case, or the website as we are talking about. So I thought about how to get out of this duplicate zone, and I found actually two interesting answers. The first one is that you should be like extremely experienced in coding, and you can find things that are what we call zero-day vulnerabilities. They are really very hard to do, and you actually need more years of experience just to build this amount of technical knowledge that enable you to report those kind of vulnerabilities. But there is a much easier way, which is just wear your thinking hat. Think about the business model. Think about what's logical and what's not logical. So let me give you an example of something that is a logical vulnerability, just for you to understand how this can slip. So imagine that you are on an e-commerce website, something like Amazon, for example, and then you are buying your goods, and all of a sudden you are buying something for $100, for example, and then while checking out, you find out that you can manipulate the price to like $1, and all of a sudden you got your items instead of $100 with $1. This happened because basically there is no check on that. So of course this won't happen in Amazon, but it may happen in other side that they don't check if you manipulated the price. So you can get your thing at a very discounted price because this kind of check is not working. Think about providing a negative number, for example. So you just manipulated the request going to the server, added a negative number, and now instead of just getting the goods for its real price, the negative price may be, for example, mapped to 0 or to any other unknown or uncatched behavior, and you end up getting those items for free. So this is an example of a logical vulnerability. And as you can see, you just need to think like a bad guy to do it. It doesn't need deep knowledge of coding. It doesn't need deep knowledge of security. Just think like a bad guy. Understand the business model and attack it. It's hard. For an e-commerce website, the worst nightmare that they can have is people buying goods for free. If you do that, the business model will collapse, and eventually you will win. So let's go along and just dive into a very short theoretical introduction to business logic. So we will borrow some definitions from our friend at OWASP and Portswigger. In case if you don't know them, I would greatly encourage you to go and reach out to them because they are like the core foundation in security, especially in web security in that case. So they define logic vulnerabilities, or what we call business logic vulnerabilities, as those vulnerabilities affecting the business model. And the unique thing about business logic vulnerability is that they exist in the business model itself, in the process. It's not about the code. It's not about finding vulnerability that will make the code go crazy. It's about finding this unhandled edgy case, thing that the developer might have overlooked. For example, providing a negative amount of money that would simply allow you to buy things for free. Or, for example, finding a way to double your points whenever you are buying from something. So let me give you an example. Loyalty programs exist, and they are very abundant. And now think about going to a shop and then buying things for $100, so you get 100 points. So if you can find a way to turn those 100 points to like 1,000 points, and then use those 1,000 points to buy other goods, since you are a very loyal customer in that case, this is a logical vulnerability. Because, for example, the shop would say, for every $100, we are giving you back $5 as points. But if you can get 50 or 500, this means that you might be taking goods at a very reduced price, or even coding the shop to give you money back by having more points than what you have actually paid for. So this is one example of business logical vulnerabilities. It attacks the core of the business in that case. So let's go away from theory and let's take a very simple case study regarding one of the things that have really a lot of logical vulnerability in it. So invitation systems. And basically, I usually refer to email-based invitation systems. So email-based invitation systems are extremely simple. Let's take the case of, for example, having Facebook groups. And in Facebook groups, you just have this kind of nice invitation. Somebody is inviting you to join their group, and this invitation link is present on, is sent to you on your email via a group member or a group admin. And we want to think together, what can go wrong? What exactly can go wrong into this invitation? So you see this kind of invitation. It's HTTPS. So I know somebody would say, maybe it's unencrypted. No, it's really well encrypted. And they have taken this kind of precautionary thing to make sure that the connection is very well protected. But like really a lot of things can go wrong beyond this point. So let's have a look. For example, you can find here a parameter called group ID in that case. This group ID seems pretty interesting to me. You have group ID 1 to 3. What if you change it to 1 to 4? Maybe you are able to join groups that you were never invited for. This is one interesting thing. So if there is no check on the group ID and the request just go through, you might be able to simply join another group without being invited to it. And then there is the sender ID. Imagine that groups would display who actually invited you to this group, similar to some application which displays this. Clubhouse used to do that, for example. So imagine that I can simply make somebody so famous, like Mark Zuckerberg, for example, invite me to a group, and then everybody will see that this guy invited me to this group. So I would take a lot of credibility because I know Mark Zuckerberg, and it's actually Facebook saying that I know that guy because they say he invited me to this group. So if simply I change the sender ID and it works, congratulations, now I get a lot of credibility that I don't really deserve, or it's not really true in that case. Another thing is the member type. So, and you see member type 1. As computer scientists, we know things usually start from 0. So the first thing I will think of, maybe member type 1 is a normal member and 0 is maybe an admin, for example. So I would try to manipulate this one. And instead of joining the group as a mere member, why not join as an admin in that case? So I will change the 1 to 0 and then see. Maybe it will just cause me to join as an admin in that case. Other things might be this kind of token. So this token, for example, maybe this token is there to check that the invitation is valid. But what if I remove the token altogether? What will happen? Will the invitation still work? Is this token really poorly formulated? So it is just, for example, my email. So I can just change this email and everything will work. So this is another point. So this token is pretty important, for example. If it's really short, can I brute force it? All of this just exists in a single innocently looking URL. But all of these are visible. And now let's put our thinking hat on and think beyond what we see. So let me think about that. This invitation is intended to a single person. So a single person should be able to use this invitation to join a group. But what if you can share it with your friends? So let's assume that this group, only admins are allowed to send invitations. So whenever you want to join the group, an admin should invite you to this group. But now you have known that this link can allow you to let your friends join the group. So now you are escalating your privileges to more or less an admin privilege by sharing this link with your friends. They are all in the group, and instead of just having this single person, you are inviting your whole friends and family to join this group. This is a logical thing. Why? Because the developer just didn't check that whenever the link is used, just go expire it. So this is one example of things beyond what we see. Another thing is what will happen if you are removed from your group. So imagine that you're a troublemaker, you joined using this invitation link, the admin know that you are doing bad stuff and just remove you from your group. And then all of a sudden, you just click the link and hooray, you just join back the group that you just left because the link never expired. This means that the admin can never remove you from the group and you are maintaining persistent access, maybe to a work group, for example. So you are accessing confidential information, maybe, which is a problem. And this is, again, something beyond what we see. Just put your thinking hat on and the possibilities are limitless. So enough with this example, because you might think that it's a theoretical one, but let's see something practical in a really known application. So today we'll be having two very interesting case studies. The first one, I call it how to create friendships that last forever on Facebook. And the other one is how to become an invisible stalker on Instagram. And I would assure you that they are pretty interesting and can be exploited by really somebody with no technical knowledge at all, which is pretty interesting to me. So let's go to the Facebook case. So back in the days when Facebook was really less famous than now, Facebook would tell you, okay, you are on Facebook. Why don't you just invite your friends? So just enter their email address and we will tell them, okay, Ali wants to invite you to join his Facebook account. Please go and join his Facebook account and so on. Of course, this feature is no longer available because Facebook now is like a billion user company, so they don't do that anymore. But back in the days, this happened. And the flow was as follows. You just send your friend an email, and when they join Facebook, Facebook automatically adds you as their friend because they assume that you are inviting your friends. So instead of having the hassle of inviting somebody and then sending them a friend request, Facebook said, okay, let's combine those together. You invite somebody to Facebook and they automatically become your friend. Up till now, there is nothing bad with that. So what happened that you invite somebody to Facebook, they join and they are added as your friend. Now what? Now, simply you had a fight with them, you are no longer friends, and you decided to remove them from your Facebook. So you just go along and remove the person from your Facebook, and this should be it. But this friend is a bit smart, and he thought, okay, when I joined Facebook the first time, Ali was added as my friend. Now I want to force Ali back to be my friend for whichever reason. One very interesting reason is that I want to see his friends only posts, for example. So what can I do? It's pretty simple. Just go back to this link invite that was sent to your email, re-click it again, and you are just re-accepting it. And this really happened. So this is not a hypothetical scenario. This vulnerability existed in Facebook in real. So you just go, accept the invite again, and I will be added to your account, and I can do nothing about it. And you can do that presumably any number of times. Like, even if I blocked you, you can still return me as friend, which is super weird, yet this was what really happened. So why did this happen in the first place? Because the invitation that Facebook sent has no expiry date. It has no expiry limit, so it can be used once, twice, and thrice. I'll tell you something even more interesting. You can use the same invite for multiple people. So it's not just that I will re-add this person who invited me once again. I can just distribute the invite, and whoever gets the link is Ali's friend by force. Ali can do nothing about it. They can just remove them, and what happened is I will just click the link again. So it's like a permanent friendship that will live forever in that case. So that's it about Facebook invitations. And now we'll be moving into another interesting case study by Instagram. So let's think before digging into the details of Instagram and think about the dream of a stalker. Like, of course, I'm not encouraging you to be a stalker. This is not really nice. But let's think hypothetically about what a stalker would like to have. They would like to have a permanent access to the person they are stalking, basically. So they want to be having some kind of permanent access to the account. All the posts they have access to, there is no friends-only posts that are hidden. They have like full access to everything. The other thing that we'd like to be is not being detected. This is like the nightmare of every stalker. If you are detected, you are dead. So everybody would like to remain hidden and silent, and that's what stalker really wants. And then happy stalking. If you have those two conditions, you are actually in like the paradise of stalking in that case. So let me tell you how this happened back in the days in Instagram. So Facebook has just acquired Instagram. This was in 2015. And then Instagram had, and still have actually, those features of blocking and following people. So whenever you want to be friends with people, you just follow them. Whenever you want to actually say, I don't want to see you again in my life, you just block people. But those things were not really connected in a logical way. How is that? So if we think in a logical manner, it shouldn't be the case that you are able to follow somebody and block them simultaneously. You either want to be their friends or don't want to see them again in your life. Doing both is really not logical. But Instagram or the developers didn't really catch this case. So what you could do basically is block somebody and then simultaneously follow them. So here is what happened. When you block somebody, Instagram would prevent them from seeing you, from seeing your profile, from seeing anything related to you. They can't see your posts, they can't search you, nothing at all, which is the perfect blocking mechanism. I don't want somebody that I blocked to reach out to me in any way. Perfect. And now what happens when you follow somebody? When you follow somebody, basically, you can see their posts. You can like their posts, you can comment on their posts. And what happened is the mix of posts. So you block somebody, they can't see you. They can't know that you are in their follow list because you followed them after blocking them. So you are in the follow list, but you are not seen. They can see your comments or likes, so you can comment on their images, but they can't see it. All their friends can, but they can't. So even if they know that you are there somehow, and there is no way actually to know that you are there because they can't see your comments. So imagine just going on writing comments on somebody's picture. Everybody is talking about this comment, and they can't even see you. Why? Because you blocked them. But simultaneously, you are following them. So by combining those two features just from the UI, no burp proxy, nothing at all, just go to the UI, block somebody and follow them, and the bug is manifested. You are in their account. They can't remove you. You have access to all their images, and that's it. And now this is stalker dream come true. Of course, again, this is just because the two flows were not linked. Maybe the people implementing the follow flow and the block flow are totally separated, so they didn't touch each other code. They didn't see how those collaborate in a sense. So again, this is basically about Instagram. And with this, we are done with our case studies. I would just like to share some final thoughts with you. So a good question would be, as a bug hunter, how to kick off finding business logic vulnerabilities, for example. And I would tell you the best thing you can do is to use your thinking hat. Understand the business model. Before you just go on and find vulnerabilities in a web application or a mobile application or whatsoever, use it as a normal user for a few days, even up to a few weeks, just to make sure you understand every bit of it. You understand what is important and what is not important. Let me give you an example. If you were able, for example, to find the email of somebody on Facebook and they have their email as only me, you get, I think now you get around $10,000 according to their bug bounty program. So $10,000 because you get the email of somebody by knowing their account. This is like insane. But if you find the same vulnerability in a company that is not social media or is not really critical on this kind of information, most probably you are getting nothing. So for example, you go to Gmail or to Google and you tell them, okay, I can know the Gmail of people. Like, this is a service. How can you send an email to somebody without knowing their Gmail? It's not a vulnerability. So this is related to the business model. If you care about privacy, or if the privacy is important to you, you pay too much. But if it is a service that you provide by providing the email address, it's really logical that everybody would know it in that case. The other thing that comes really in handy is read a lot of reports. And really, HackerOne published reports is really a good resource because you can see what others have found in this topic, and really things more or less repeats themselves. So usually social media platform would have the same business model. E-commerce website would have a same business model. So if you find the vulnerability in Amazon, chances are they might exist in things like eBay too. Of course, there is no guarantees, but you can try your luck in that. About future work and what I'm planning next. So currently I'm working on some kind of framework to automate some kind of testing on business logic, because the issue with business logic, it's really hard to automate this stuff. It's about thinking. But what you can basically do is automate some things related to your knowledge of business logic. So for example, the vulnerability that I talked about in changing the price, you can automate that. You just, on checkout, just change the price somehow. So you embed your knowledge into this kind of framework to automate things. I'm also working on another very interesting topic related to payment integrations and how to use those payment integrations to kick off websites. So a really big website can be kicked off by attacking their payment integration, but this will be coming in the next section of the series, maybe next year. Finally, I would like to thank those three people, because without them, I wouldn't have been here today. So at Symbian, Simo, at Zigo, and at Sermatrix, those guys really helped me when I started, and I am wholeheartedly thanking them for that. So thank you for your time, and I will be glad if you have any questions. Thank you.